Hi all, my name is Shalini. I am working as an assistant professor in St. Joseph Institute of Technology, Chennai. Today I am going to take a topic on problem solving agent and artificial intelligence. Okay, in problem solving agent, how we solve the problem using AI. We mostly use searching techniques to solve the problem. So some of the searching techniques used in solving the problems are breadth first search, depth first search. So some of the examples we see in searching techniques are chess problem, towers of Hanoi, water jug problem, okay, travel salesman problem, travel salesman problem. So these are the examples of AI. So we use searching techniques to solve these examples. So these are the like chess problem, towers of Hanoi, water jug problem, travel salesman problem. These are the examples which is used in AI. Using the searching techniques we will solve the problem. So some of the process there are totally 5 steps to solve this process in AI. What are the 5 steps are? The process of solving problem in AI has totally 5 steps. We have 5 steps. What are the 5 steps are? First we need to define the problem. We need to define the problem. First one is define. So define the problem is we need to know what is the input from the user, what are the inputs we are getting from the user and what will be the expected output we are giving to the user. So both we need to know. While defining the problem we need to know both what is the input and what is the output. So in defining the problem need to know input and expected output. Next one is analyzing the problem. Analyzing the problem. So in analyzing the problem we need to know what are the conditions we are using for the question to solve the problem. So what are the conditions we are applying on the input to solve the problem. So we have to analyze the problem and we have different kinds of rules to be applied on the problem. So we are going to apply that. So we need to know the condition to apply, right. Next, after this the next step is choosing the analyzing the problem. Next is identifying the solution. Now after analyzing the problem we need to identify the solution. Then how we will identify the solution is we will apply different types of methods on the problem. So we will apply different types of method on it and we will get infinite number of solution for the problem. So infinite numbers of solution we will get by applying the method. So we have n number of methods to solve the problem. So we will apply different types of methods and we will get different kinds of solution. And next is choosing the solution. So we will know that what is choosing a solution. It is nothing but taking the best result out of it. So we have to take what is the best result. So we will get n number of solution here itself. In identifying the solution itself we will get n number of solution. From that we will choose which is the best solution on it. So here is choosing the best solution, right, choosing the best solution. and then after choosing the best solution, we will take that best solution, that problem solving solution we will take and we will implement. Okay. The last step is we will implement it. We will implement on it, right. So these are the 5 steps here: define the problem, analyzing the problem, identifying the problem, choosing the solution, and implementation. If we apply this 5 steps only, we will get the result. So we will search through this steps only. First we need to define it, analyze it, identify it, choosing the solution, and implementing it. Okay. So here we have defined about we will define the problem in the what are the process in 5 steps we have defined it. So in that we will have problem formation. So we have 5 steps in problem formation. One is initial state, next is action, next is transition model, goal test, and path cost. So to solve a problem, we have to check each of the state so that we get the goal state. So first one is initial state. Initial state is nothing but the question what we are getting. Okay, the question what we are getting, it will be our initial state. And next is action. What is an action is what are the moves we are going to take to get the result. So what are the number of moves we are going to take to get the result. Action is nothing but moves. Total number of moves we are going to take to get the action. Next is transition model. We call this as an intermediate result. Right. We call this as an intermediate result. So after performing the action, what we do is we get a result. Right. After performing an action, we get one result. That result we called it as transition model. Okay. On the transition model, we will check whether it is satisfied with the goal state. So if it is satisfied with the goal state, we will finally say it has reached this goal state. Or else what we do is we will move on for the goal test. What is goal test is we will compare with the transition model and the goal state. If both are equal, it has reached the goal state. Or else what does it do is we will continue with the action. Okay, it will form as a loop. So if we see with an example, you can clearly understand what we can do with this 5 steps. So next is path cost is total number of moves we are taking. What are the how many total number of moves we are taking, that will be our path cost. So it will be in a numerical digit values. Okay, that is the path cost. For example, I am taking a 3 cross 3 matrix, right. I am taking a 3 cross 3 matrix, that is an 8 puzzle problem. My 8 puzzle problem is, for example, this is my question. So this is my question, right, and my goal state is this should be my goal state. So this is my, here first initially what I said, initial state. So this will be my initial state, right, and this will be my goal state. So how we formulate a problem is, first we have to check what is the initial state. So in this example, this will be my initial state, and what is the next step? Action. Action is nothing but, in this question we are getting the question like the actions, what we can do is we can move it to right. Okay, we can move left, a number to left, or we can push the number from up or from down. So our action is left, right, up and down. In this problem our action will be left, right up and down. These all actions we can do in this problem. So this will be our action. So here for example, I am going to do an action pushing this 4 to right side. So what will be my answer here? Here my answer will be 5, 8, 2. So I am pushing this 4 to here in the middle. So this will be my answer here. So now I am getting some result, right? So this result will be my transition model, that is called as an intermediate result. As of now I am getting one result, that is called as a transition model. We call this as TM. That will be my intermediate result. Now after this what I am doing is I am going to goal test it. Goal test is nothing but we have to compare this transition model with our goal state. You tell whether it is same or not. No, it is not same. So here what we do is again the loop will be repeated. So again the TM will be now be converted as an initial state. Now this will act as an initial state again. So this will be initial state now. Now again we have to perform some of the actions, like in this initial state my actions will be down, left and up. So these are all actions I can perform in this initial state. So if I am pushing this 5 down here, right, my answer will be 8, 2, 5, 4, 3, 1, 6, 7. So one action I have performed here, and now here this will be my transition model. So this will be my transition model. I have to check whether this transition model, this intermediate result is equal to the goal state. Now this is not equal. So again the loop will be followed and then again moves to initial state. So I am converting this transition model into initial state. So like this we will perform n number of times. So n to get the result of the goal state. So here we have to define what will be the path cost. So how many times we have to do to get the result. Here is in 3x3 matrix we have to get the path cost in 3x3 matrix is 3 power 20 times. If we do 3 power 20 times, within 3 power 20 times we will get one goal state. So we have to take that as a goal state, so to get the result. So this is called as a 3x3 matrix 8 puzzle problem, right? So next is in problem solving agent, the next problem is vacuum world problem. So next is vacuum world problem. Here my condition is like there are two rooms A and B. In both the room we will have some dirt inside the room. Using the vacuum I have to clean both the rooms. The A and B room should be cleaned. So here this is my problem here. I have both room A and B and we have some of the dirt inside A and dirt inside the B. So my final answer should be, my solution should be A and B should not have any dirt. Okay, so what are the possibilities in such a case, like both the rooms should be clean. So here I am applying a vacuum inside it, right? So this will be my initial state. So next will be my actions. So here in this problem my actions are, I can move left, I can move right, the vacuum can move left, the vacuum can move right and the vacuum can suck the dirt, right. This will be my moves here, actions. So initially first case I am moving this vacuum to right. Okay, I am moving from this initial state, I am moving the vacuum to right. If I am moving the vacuum to right, but I am not taking the dirt from A, but only I am moving the vacuum to right. But I have dust inside B as well. So first action is right. Next is left. So I can't move this any more from left here. So it will be inside the A only, A room only, this vacuum. So my left will be as a loop, right. Next action here is yes. Yes is nothing but suck. We can remove the dirt from the A. So here my first action is yes. Yes is nothing but removing the dirt from A. So A, B, I have B inside, dirt inside B, and I am going to remove the dirt from A using the action yes, suck. So this will be my new transition model. This will be my transition model here. Transition model will be here. So we have to check whether this will be a goal state or not. Is it a goal state? No, because what I have said, what will be my goal state? Both the rooms should be clean, but here only one room is clean. Here we have dirt inside the B. Again here we need to apply the action. 3 actions. What are the actions? I can move the vacuum to left, vacuum to right, or I can suck the dirt. So here we can't move the vacuum to left because it is already inside the A only. The vacuum is already inside A. So I am going to move, I can't move, so I am creating a loop here. And now here we can move the vacuum to right. So I am moving the vacuum to right here. Right is nothing but moving the vacuum to the B room. Right. And next action is left, right. One more action is suck. Here we can't do suck here because already we have removed the dirt here. So again it will form as a loop because already in A we have removed the dirt. So this here in this action it is created as a loop itself. So 3 actions in this transition model. In this initial state we have done 3 actions. One is left, one is right, the other one is suck. So here now this will be our new transition model. So what is a transition model? This will be a new transition model. On this again we have to apply this initial state. This will act as an initial state and we have to apply the action, that is left, right and suck. First initially left. Left means if you move this vacuum here inside the A room, it will come like this condition only. So this arrow of left will remain as this condition only. Right action, if you are going to do the right action, it will be inside this loop only. We can't move behind this B. So this will be our right action. The next action is removing the dirt, that is yes. So we have to remove the dirt using the suck. So I am removing the dirt here. So this will be our new transition model and we have to check whether this is correct or we have reached the goal state or not. Check it whether it is goal state or not. In both the room we are not having any dirt here. So it has reached a goal state. Next what we are going to do is, this is our new transition state. Okay, this is another condition. The condition is the vacuum is inside the B. The vacuum is inside the B. So what we are going to do is, here we are going to take an action left, right and suck. So if you are going to left means it will be reaching this condition only. If you are going to right means it is inside, it is formed as a loop, and the other one is S condition, right. The other one is S condition. S is nothing but removing the dirt. Okay, what is the removing the dirt means? We are removing the dirt from this B room. So we are removing the dirt from the B room, but the dirt is inside the A in this state. So now this will act as a new transition model. We have to check whether it is reached to goal state or not. Here it is not reached to the goal state. Again we need to apply the action considering it as an initial state. Actions are 3 actions. One is left, right and suck. Here right we can't go behind the B room. So the right will be formed as a loop only. Again left. Move the vacuum to the left room. we are moving the vacuum to the left room with the dirt inside the A. So this will be one of my action. So next is right left we have done. One more action is left, that is suck. Suck we can't do because already the condition is in this room already the suck has been done and there is no dirt. So it will form as a loop only. Now again we got a new transition state, A room which has dirt and a vacuum inside it, B room which is clean. Again we need to apply the action on it. Three actions are there, left, right and suck. So left it can't move, right same condition, this condition only will come, and again S is nothing but removing the dirt from the room, A, B and suck condition, removing the dirt from the room. So this will be our new transition model. We have to check whether this transition model is equal to our goal state. Yes, it is equal to our goal state because we don't have any dirt inside the room. So for the both condition, whether the vacuum is inside the A room or the vacuum inside the B room, we need to get we need to get this condition. And again on this also we have to apply all the three actions, that is right, left and suck. If you do right, left, suck also, it has to be clear, like both the rooms should be clear. So we have to apply both three actions on both the condition as well, left, right and suck. If you move this side, right side, left side also, we have to get the same result. So the path cost of this condition, so the path cost of this problem is 3. For 3 times if you move this condition, we will get this answer, like A and B will not have dirt finally. Okay, this is the vacuum world problem. Okay, the next problem is the water jug problem. In water jug problem we have 2 jugs, that is one is X and one is Y. Here the one jug is of 4 liters, the other jug is of 3 liters, right? But here we have some of the conditions, like this jug is not measured, there will be no measuring on this jug. In 4 liters jugs and 3 liters jugs there will be no measures. So here we need to solve a problem in such a condition that initially we don't have water inside it, that is the X will be like the first jug will be 0, 4 liters jug will be 0 and the Y, that is 3 liters of jug will also be 0. The final condition what we have to get is in X, that is in 4 liters of jug we have to have 2 liters of water, and in Y there should be empty. So there should be no water inside it. So this will be our final condition. So this will be our goal state. So how many moves, how many actions we are going to take to get the result, that is our actions. So that will be the answer, how many moves we are going to take to get the result. So how we are going to solve this problem? So some of the conditions we have to solve this problem is there is no measuring on the cups, that is we don't have measures on 4 liters of jug and 3 liters of jug. We can pour the water outside also. If we have water inside it, we can pour the water ground, or we are also having a tap so that we can fill water whenever we are required. So these are all the conditions we are having to proceed this problem. So the first is, like initially we are starting with X is equal to 0. So there is no water inside 4 liters of jug. Y, there is no water inside Y jug also. So then with the help of the tap we are filling the 4 liters of jug. So if the jug is full means what? Like there are totally 4 liters of water inside the jug. So there are totally 4 liters of jug inside the water. In Y we are not filling any water inside it. So in Y there is only 0 liters of water. Then again this will be our new transition state. So we need to check whether this is equal to the goal state or not. No, this is not equal to goal state. Again we need to perform the action on it. So what we are going to perform action is, we are going to pour this water, 4 liters of water inside Y. 4 liters of water which is full, we are going to transfer it into Y. So from X we are transferring it to Y, that is until it is full. So what I said, this is how many liters of water? This is of 3 liters of water. If it is full means it is measured as 3 liters inside it. So how many liters left inside the X is? There are only 1 liter left inside the X jar, right? Then again this will be a transition model, and we need to check whether it is reached to goal state or not. It is not reached to goal state because our goal state should be 2 in X jug and 0 in the Y jug. So again we need to perform the action. So what we need to do is we need to empty the water which is filled in Y jug. So we are emptying it, that is 3 liters jug, we are emptying the water, and in X jug it is like 1 liter of water, it is present, already present. So next is, the next condition what we are going to do is, we are transferring the X, which is 1 liter of water which is present in the 4 liter jug, we are transferring it to into Y. So now what happens is, the X will be 0, that is the 4 liter jug will be empty, okay, and Y will have 1 liter of water, as the water is transferred from X jar to Y jar. So X will be empty, Y will be 1. So now again we need to check for the transition state. This will be the intermediate goal result. We need to check with the goal state. We need to check whether it is of goal state or not. It is not on the goal state. Again what we need to do is, we need to, using the tap, we need to fill X jar, that is 4 liters of water inside it. So it is filled and Y has only 1 liter inside it. So if X is full means how many liters are there inside it? We have 4 liters of water inside it, and Y we have 1 liter of water. Y we have only 1 liter of water. Then what we are going to do is, we need to transfer this X into, what we are going to do is, we need to transfer this X which is of 4 liter into Y until the Y is full. Until the Y is full means the Y should be of how many liters? 3 liters. If Y is full means we have totally of 3 liters of water inside it, right? So if we fill all 3 liters inside the water, how many liters are remaining here? We have 2 liters of water remaining here, and Y is totally full here. So this will be a new transition state. We need to check with the result. This will be a new transition state, and we need to check with the goal test whether this has reached a goal state or not. It has not reached the goal state, and we will consider this as an initial state again, and we need to perform the action. So after what we have to perform the action is, we need to empty this Y jar. We need to throw the water into the ground. So we need to throw the water into the ground, and remaining what we have in X, we have 2 liters of water inside it. So finally how much we are getting? In X how many liters are there? 2 liters are there. In Y we are having 0 liters of water. So here, so from what we have started, initial state is like X we have initially started with 0 liters, and Y we have started initially as 0 liters, and finally we got the answer as 2 liters inside the X and 0 liters inside the Y. And actions what we are going to perform is pouring the water from one jar to another jar and measuring the levels, that is whether it is 4 or 3 liters in X and Y. These are all the actions we have performed it to get the result, that is an water jug problem.